Hello everybody, welcome to the course on graph algorithms. The first unit in this course, we're going to be talking about various algorithms to compute various sorts of decompositions of graphs. But to begin with, we're going to start with the very basics about what is a graph, what are they good for, and how do we sort of interpret them and draw them. So to start with, a graph is sort of an abstract idea, and it's an abstraction that sort of represents connections between objects. And graphs are useful both in computer science and elsewhere in the world because they can be used to describe many important phenomena. For example, the internet often can be thought of as a graph, where you've got various web pages and they're connected to each other by links. And this is sort of a very, very high level view of the internet that sort of pays no attention to the content of a given page and other things like that. On the other hand, if you want to do something like Google's PageRank algorithm, makes sort of heavy use of sort of this very high-level view of the internet and connectivity within it. Another example is maps. You can think of maps as a graph, sort of where you have intersections that are connected by roads. And this is a view that would be very useful if you, say, wanted to plot a course between two locations. You need to find some, connection, some path along this map that gets you from one place to the other. Social networks can also be interpreted as graphs. You have people connected by friendships or following relationships or whatever, and this provides you another example of a graph structure. You can also sort of use more complicated things. If you have some sort of robot arm that can be in many possible configurations, what you could do is you could think of sort of the configurations are some of them are connected to each other by various motions. And then if you want to solve problems like how do I best reconfigure this robot arm from this position to this other position, you again want to sort of consider this graph relating these things to each other in order to figure out how best to do that. Okay, so these are the sorts of problems that we would like to be able to deal with using graph theory. So what is a graph? Well, the formal definition of an undirected graph, we'll talk about directed ones in a few lectures, is that it's a collection V of vertices and then a collection E of edges, each of which connects a pair of vertices to each other. So when you draw them on the paper, what you do is your vertices are usually drawn as points or circles or something, and the edges are lines or curves or something that connect pairs of these points. So, for example, the graph drawn on the screen has 4 vertices labeled A, B, C, and D, and it also has 4 edges, one between A and B, one between A and C, one between A and D, and one between C and D. And so, to make sure that we're all on the same page, if we drew the following graph below, how many edges does it have? Well, the graph here has 12 edges. You can sort of count them all, and sort of each of these segments between 2 of these points gives us an edge, and so there are 12 of them. Now, there's one thing that sort of fits into this definition of graphs that I gave that is a little bit weird, perhaps, or unusual. One thing that you might have is loops. This would be an edge that connects a vertex to itself. So here we just have the one vertex A and then a loop that connects A to itself. And there are some instances in which you might want to use this. Sometimes you actually do have, a traffic circle that just goes in a loop or something like that. But only sometimes is this sort of a thing worth talking about. Also, sometimes you can have multiple edges between the same pair of vertices. So in this picture, we have 2 vertices A and B and 2 edges between them. And somehow, if you're just talking about can I get from A to B, it doesn't matter if there's 1 edge or 2 between them. But sometimes having both of them is relevant. On the other hand, a lot of the time, these loops and multiple edges are just sort of a degeneracy that we don't really need to deal with. So oftentimes we work with what are known as simple graphs, which are graphs which don't have loops and don't have multiple edges. And so this is sort of the basics of what a graph is that we've just covered. Next time, we're going to talk about a couple of things. First, we're going to talk about how to represent graphs on a computer. And then we're going to talk a little bit about how we talk about runtimes for graph algorithms. So I hope this has been a useful introduction, and I'll see you at the next lecture when we talk about these other things.